When wiring basement walls insulated with Polaris foam, several options exist for both unfinished and finished basements. For unfinished basements, firstly, consider using Romex cable and conduit. This involves running Romex cable, which is a type of non-metallic sheathed cable, through either rigid or flexible electrical conduit. The conduit acts as a protective barrier for the cable. Secure the conduit to the wall studs using straps or clips. At each electrical box, use a conduit body to protect the cable entry. This ensures that the cable is not damaged as it enters the box. Secondly, another option for unfinished basements is using ENT conduit only without Romex. In this method, install ENT, which stands for electrical metallic tubing, conduit directly on the wall studs. Then pull individual conductors, which are the wires themselves, through the conduit. Attach electrical boxes to the conduit using conduit bodies, which provide a secure and protected connection. For finished basements, firstly, one option is to use USB cable. USB cable is a type of underground feeder and branch circuit cable that is designed for direct burial. You can run direct bury USB cable on the foam wall, but this is only suitable for below-grade applications, meaning the portion of the wall that is underground. Use electrical boxes with integral weatherproof covers to protect the connections from moisture. Ensure the cable is protected from physical damage, for example, by installing a baseboard along the wall. Secondly, an alternative for finished basements is to use conduit with MC cable. Install conduit on the wall studs or behind the drywall. Then, pull MC, which stands for metal-clad cable, through the conduit. Attach electrical boxes to the conduit using conduit bodies. This method provides a high level of protection for the wiring. When selecting electrical boxes, it's recommended to use PVC or metal electrical boxes with weatherproof covers. These boxes are durable and resistant to moisture. Look for boxes with built-in nail plates for securing them to the foam walls. These nail plates make installation easier and more secure. Here are some important installation tips. Firstly, use non-metallic fasteners to avoid piercing the foam wall. Piercing the foam can compromise its insulation value. Secondly, ensure that conduit and cables are secure and protected from damage. This will prevent future problems and ensure the safety of the electrical system. Thirdly, keep cables off the floor to prevent moisture damage. Moisture can corrode the wires and create a safety hazard. It's crucial to follow all applicable electrical codes and consult with a licensed electrician for safety. Electrical work can be dangerous, and it's important to ensure that it's done correctly. There are also some additional considerations to keep in mind. Regarding depth, USB cable can be buried up to 24 inches below grade. This is important to know if you are running the cable underground. With respect to temperature, protect USB cable from excessive heat or cold. Extreme temperatures can damage the cable and reduce its lifespan. Expansion and contraction should be taken into account. Allow room for movement due to temperature changes. Materials expand and contract with temperature fluctuations, and it's important to accommodate this movement in the wiring installation. Moisture control is also important. Consider installing a vapor barrier behind foam walls to prevent moisture buildup. Moisture can damage the foam insulation and create mold problems. When using Romex and conduit, firstly, choose the correct size of conduit for the number and gauge of wires being installed. The National Electrical Code, or NEC, provides tables that specify the maximum number of conductors allowed in different sizes of conduit. For example, NEC Table 310.15b16 provides ampacity ratings for conductors based on insulation type and temperature rating. Make sure the conductors chosen have an ampacity suitable for the overcurrent protection device, such as a circuit breaker, protecting the circuit. Secondly, when running Romex and conduit, use proper fittings and connectors to ensure a secure and watertight connection. This is especially important in damp or wet locations. Thirdly, ensure that the conduit is properly grounded. This is typically done by connecting a grounding conductor to the metal conduit at each electrical box. When using ENT conduit only, firstly, properly ream the cut ends of the conduit to remove any sharp edges or burrs. Sharp edges can damage the insulation of the conductors. Secondly, use appropriate fittings and connectors to join sections of conduit together. These fittings should be listed for use with EMT conduit. Thirdly, pull the individual conductors through the conduit carefully to avoid damaging the insulation. Use a pulling lubricant to reduce friction. When using UFB cable in finished basements, firstly, ensure that the cable is properly supported and secured to the wall. Use cable staples or clamps that are specifically designed for use with UFB cable. Secondly, protect the cable from physical damage by installing a baseboard or other protective covering. Thirdly, make sure that the cable is not exposed to direct sunlight, as this can degrade the insulation. When using conduit with MC cable in finished basements, firstly, choose the correct size of conduit for the MC cable. Secondly, use appropriate fittings and connectors to join sections of conduit together. These fittings should be listed for use with rigid or flexible conduit, as appropriate. Thirdly, ensure that the MC cable is properly grounded. The metal sheath of the MC cable typically serves as the grounding conductor. When installing electrical boxes, firstly, choose boxes that are appropriate for the location and application. For example, use weatherproof boxes in damp or wet locations. Secondly, ensure that the boxes are properly secured to the wall studs or framing members. Thirdly, use cable clamps or connectors to secure the cables to the boxes. Regarding installation tips, firstly, always turn off the power to the circuit before working on any electrical wiring. Secondly, use a voltage tester to verify that the power is off. Thirdly, wear appropriate personal protective equipment, such as safety glasses and gloves. When considering depth for UFB cable, remember that the 24-inch burial depth is a minimum requirement. In some cases, a deeper burial depth may be required to protect the cable from physical damage. With respect to temperature, avoid running UFB cable near heat sources, such as furnaces or water heaters. When allowing for expansion and contraction, leave some slack in the wiring to accommodate movement. Avoid pulling the wires too tight, as this can cause them to break. With regards to moisture control, ensure that the vapor barrier is properly installed and sealed to prevent moisture from entering the wall cavity. In addition to these specific recommendations, it is always important to consult with a qualified electrician to ensure that the electrical wiring is installed safely and in accordance with all applicable codes and regulations. Remember that electrical work can be dangerous, and it is always best to err on the side of caution. When choosing wire sizes, firstly, consider the ampacity requirements of the circuit. The ampacity of a wire is the maximum amount of current that it can safely carry. NEC Table 310.16 provides ampacity ratings for different wire sizes and insulation types. Secondly, consider the voltage drop in the circuit. Voltage drop is the decrease in voltage that occurs as electricity flows through a wire. Excessive voltage drop can cause appliances and equipment to malfunction. The NEC provides guidelines for limiting voltage drop in branch circuits and feeders. Thirdly, consider the ambient temperature in the area where the wires will be installed. High ambient temperatures can reduce the ampacity of wires. The NEC provides correction factors for adjusting ampacity ratings based on ambient temperature. When installing electrical boxes, firstly, consider the number of wires that will be entering the box. The box must be large enough to accommodate all of the wires and connectors. The NEC provides guidelines for calculating the minimum box size required for different wiring configurations. Secondly, consider the type of wiring that will be entering the box. Different types of wiring require different types of connectors. Thirdly, consider the location of the box. Boxes installed in wet or damp locations must be weatherproof. When running conduit, firstly, consider the type of conduit that is best suited for the application. Rigid metal conduit provides the best protection for wires, but it is also the most expensive and difficult to install. EMT conduit is a less expensive option that is suitable for many applications. Flexible metal conduit can be used in tight spaces or where there is a need for vibration resistance. Secondly, consider the size of the conduit that is required. The conduit must be large enough to accommodate all of the wires that will be running through it. Thirdly, consider the number of bends that will be in the conduit run. Excessive bends can make it difficult to pull wires through the conduit. The NEC limits the number of bends that are allowed in a conduit run. When making connections, firstly, use the proper tools and techniques. Improper connections can cause overheating and electrical fires. Secondly, make sure that all connections are tight and secure. Loose connections can also cause overheating and electrical fires. Thirdly, use wire connectors that are listed for use with the type of wire being used. Different types of wire require different types of connectors. When grounding electrical systems, firstly, use a grounding electrode system that meets the requirements of the NEC. The grounding electrode system provides a path for fault current to flow back to the source, which helps to protect people from electric shock. Secondly, make sure that all metal parts of the electrical system are properly grounded. This includes conduit boxes and equipment enclosures. Thirdly, use a grounding conductor that is sized according to the NEC. The grounding conductor must be large enough to safely carry fault current. When working with electrical systems, it is always important to be aware of the potential hazards. Electricity can be dangerous, and it is important to take precautions to protect yourself from electric shock. Always turn off the power before working on any electrical equipment. Use insulated tools and wear rubber gloves. Never work on electrical equipment in wet or damp conditions. If you are not comfortable working with electricity, hire a qualified electrician. Remember to always consult the National Electrical Code and any local codes that may apply. The NEC is a comprehensive set of standards for electrical wiring and equipment. Local codes may be more restrictive than the NEC, so it is important to be aware of them. When performing electrical work, always obtain the necessary permits and inspections. Permits and inspections help to ensure that the work is done safely and in accordance with applicable codes. Consider using arc fault circuit interrupters or off-size to protect branch circuits that serve bedrooms, living rooms, and other areas where people are likely to be present. Off-size are designed to detect arc faults, which are a common cause of electrical fires. Consider using ground fault circuit interrupters or GFCIs to protect branch circuits that serve bathrooms, kitchens, and other areas where there is a risk of electric shock. GFCIs are designed to detect ground faults, which can occur when electricity leaks to ground. Finally, regular inspections of the electrical system are necessary.